Hey, has your teacher ever asked you what the difference is between a compiler, an assembler, and a translator? And you've gone, I don't know, man. I just don't know. Well, welcome to another episode of 5-Minute Computer Science. My name is Mr. K, and today we're going to be looking at the way you can take a program and translate it or compile it or interpret it. And what does that really mean? What are the advantages? What are the disadvantages? So let's put 5 minutes on the clock. Let's make it happen.
So you'll remember from last lesson that we were looking at translators, and there are 3 different types of translators that you need to be familiar with: assemblers, compilers, and interpreters. And we're going to look at each one now. Now bear in mind that CPUs do not like the idea of having high-level languages. They just want machine code. Very simple things, CPUs. And so a translator's job is to translate from a high-level language, turn it into machine code that the CPU can follow. The first one is assembly language. Now, assembly language is used and converted by an assembler. Okay, the assembler and assembly language go well together, easy for you to remember. And all an assembler does is it takes the source code, the bit that you've written in assembly language, and converts each line of assembly language into some kind of machine code, or the better term to remember is object code. That's what it's really doing. It takes it, it goes through the assembler and converts it. So each line is an equivalent machine code line that is assembled at this point. Now, bear in mind that assembly languages are pretty straightforward, and so this is a nice, easy conversion. But the only downside to assembly language, as I've said before, is that it's machine code particular or specific, which means you can't actually use the same assembly language on a different platform or different type of architecture. But this is a pretty easy way of converting between the source code and the object code. Right, the next one is a compiler. Now, the compiler is similar to an assembler in that it converts into machine code, but the major difference here is that it takes the source code that's been produced, okay, which has been written in a high-level language. It goes through the compiler and it produces an exe file, which means that it's a program that can be saved and run separately to the actual code itself. So a compiler does is that it goes through several times and looks at all the code for any kind of errors. If any kind of error is found, it will not compile it. But if no errors are found, it compiles it. And then you don't need the source code. You've got the actual executable file. You can run away with that. That's the main thing. And the other thing, of course, is that compilers are those that produce an exe file which will run on lots of different platforms. So it doesn't really matter if you're using different platforms once you've got the exe. An interpreter does a job similar to compilers, but it does it one statement at a time. Unlike a compiler, though, it doesn't check for errors in terms of the entire program before converting or interpreting. It only ever checks the line it is currently interpreting. So it's going to look at one line of code, test it. If it has no errors, it will translate it or interpret it and pass it on as machine code. Sounds really good, but this does slow the machine down because every single line of code needs to be checked and then needs to be converted and then needs to be executed. But interpreters are also beneficial if you want to see why and how your machine is crashing or your program is crashing, because it does stop at the point where the error occurs. Right, bytecode. Now this bytecode is slightly different because it used to be the case that interpreting each line of code was the normal way of doing things, or compiling. But a bytecode is actually in between. It's neither, it goes through the compiler, however, it's got some elements of interpreting there, and it sits in between those two, okay? And the bytecode can then be used to convert into lots of different platforms. This is typically how programming is done these days with a bytecode interpreter. So it does both compiling and interpreting in terms of its functions. Right, last few then, let's have a quick look. I also want you to bear in mind the differences here, just to recap. The important thing is a compiler will take the entire code, test it, check it to see if there's any errors. If there aren't any errors, it produces an exe file. So it takes the code, it goes to the compiler, it produces the exe file. It can then be executed. Whereas an interpreter will do one line at a time, it's interpreted, it's produced in machine code, it's executed, then the CPU asks for the next line of code, so it goes back to the code, it's interpreted, passed to the CPU, and there's a cycle that takes place here. So that takes a bit longer, a lot longer really, depending on the size of the file. However, you do need to know the difference between them. A compiler will just give you a file that you can take away, you no longer need the code, whereas an interpreter requires the code at all time.